Hey, what's up, guys? I've noticed it in a couple of channels that I watch that there's a big to-do about making gears, and that's awesome for tinkering projects. One thing about gears when you 3D print those things is they tend to be a little bit noisy, and you tend to get a lot of friction. So I wanted to see if I could help out today and maybe figure out how we could get rid of some of that friction. Now, friction you cannot avoid, but how much friction? There probably are a couple of things you can try. So I'm going to go ahead and put in a few gears and see if we can make some real quick. So these gears are on the same module of 2. They have a different number of teeth, and the ratio is going to be 3 to 1. I'm going to go ahead and combine these, knowing that I'm going to drive another gear with this, or it can be driven by another gear. Once you get these two things combined, then you're going to want to make a hole for the shaft. I find that 8mm rods are readily available for myself, so that's what I choose to do, and I oversize it just a little bit. I'm going to duplicate this so that you can see a little bit more closely what's going on. Duplicate that. Raise it up a little bit. Move it over. Now, worst case is you're going to get a lot of surface area on this overlap. If you take a top view, you can see basically from here all the way up to here, if those compress and sit on top of each other, you're going to get a lot of surface area. And you don't really want that because that's going to cause friction. Ideally, you'd have a little bit of space in between here. So that's what we're going to do. I'm going to get rid of this gear and get it out of the way because we really don't need it. I'm going to move this one over. I'm going to pick one of my favorite shapes from the search. I'm going to search for tire. There it is. Now that doesn't look much like what we want, so I'm going to change these parameters just a little bit. 55 on the whole diameter. Let's take a thickness of 3, a height of 3. Now we don't want that full 3, but we'll deal with that in just a minute. Edge radius, this will round it out nicely if we put a 5 on that. And now you can kind of see what we want to do. So the idea is to place this ring on this surface. But we don't want to do it as is though, because it's rounded on the bottom and we want a nice flat surface on the bottom. So in order to do that, we're going to go back to our tools and we're going to take the bottom half of this away. So we're going to make a hole. Now, the height of the ring is 3mm, so we're going to make this 1.5 in order to subtract half of it. Okay, let's group that. And there. That looks nice and flat. We're going to place it on here and center it. Using our work plane tool, we'll get it at the right height. And now we will align it toward the center. And there you have it. Let's group those and take a closer look. Okay, now, one more time, let's go through the exercise. Let's duplicate this and bring it up. We'll slide it over. And now you can see we've reduced our surface area of what could possibly touch if those sat down on one another and compressed. You only have this small portion of a ring as opposed to that entire face. So imagine that these were put together nicely on drive shafts and you want to fit it as compactly as you can. That's kind of what you're looking at. Now, the single piece, I'm going to take him out and show you another little trick that might reduce the surface area just a little bit. Depending on how you've pressed your bearings and things like that, this could be a problem. From here, I'm going to show you, essentially, you could have these pieces riding on each other. And they're going to be riding at different speeds, keep in mind, because of your gear ratio. Right? No, I don't think you'll be able to see this, but these are all three turning at different speeds. So you have these turning on each other. So the idea is to use a spacer in between, a narrow spacer. Now, this is not really the perfect one for the job. What you'd want to do is you'd want to print a spacer that's more narrow than your bearing. So that's 22 millimeters. You'd ideally want something like a 12 or 15 millimeters right there instead. And this would sit on top of it. And what that's going to do is, all right, you got your bearing, the intersection of that bearing will come in contact with this. So he would spin nicely. And this piece would sit on this. And so you've got something that you know is going to turn and reduce that friction. The last thing is probably the most obvious thing, is some kind of lubrication. Different things are better for different purposes. Probably for gears and things like that, you're looking at something like this. I'm not really sure how, say, a graphite would work. Graphite definitely works on metals, but usually for plastic things and things like that, you want some kind of PTFE lubricant, and that's what both of these are. This is a lot more thin, and this is just kind of greasy. Maybe a little more petroleum in it or something, I don't know. Anyway, those are three things that I hope could help you out. Hope you enjoyed the video. If you did, give me a little thumbs up. Thanks.